Hello everyone, I am Hasan Babayev, third year chemical engineering student at Baku High School. Today I will talk about applications of fluid mechanics in healthcare. Before starting my presentation, I would like to introduce my content. So we will discuss two main devices which are used in healthcare. First device is sigma manometer, and I will give some information about parts of this device and working principle. Second device is pulse oximeter, and we will discuss why this device is important and how it works. My groupmate will talk about what is fluid dynamics in details, so I will give short information about that. Fluid mechanics is the study of fluid behavior at rest and in motion. Fluid mechanics has a wide range of applications in mechanical and chemical engineering, as well as biological systems. For example, sigma manometer. Sigma manometer is familiar to most people. It is used to measure blood pressure of the body. Let's talk about parts of sigma manometer. First part is cuff with bladders, which is painted in blue in photos. The cuff is used to hold bladder around the arm during the measurement. Then there is an artery aligned mark on the cuff. To be more accurate, cuff must be designed properly with respect to artery aligned mark. Then we have bulb. Bulb is used to pump air into the cuff via tubes. Pressure control valve. Pressure control valve has an important role to get more precise measurement. So it controls the pressure of air which is pumped from the bulb to the system. The pressure gauge shows the measured value of pressure, and finally a stethoscope is used to hear sound of movement of the blood. Regarding to how this device works, there are two types of blood pressure reading, systolic and diastolic pressure. When we put the cuff around the arm and pump it up, it exerts the pressure to cut the blood flow. As the pressure in the cuff is released, blood starts flowing again, and we can hear the sound of flow in the stethoscope. The number at which blood starts flowing is the measure of maximum pressure of the heart, which is called systolic pressure. And we continue releasing the pressure on the cuff and listen until there is no sound. This number indicates the pressure in the system when the heart is relaxed, and this pressure is called diastolic pressure. The normal values for systolic and diastolic pressure readings are 120 and 80 mm of mercury respectively. Second device is pulse oximeter. A pulse oximeter is a device which is used to show a person's oxygen saturation quickly and easily. It means that this device can measure the level of oxygen within the blood, especially in arterial blood, without using any invasive means. Pulse oximeter is typically a small portable device that clips onto the finger and provides a reading within the seconds. In addition to oxygen saturation, this device provides a heart rate measurement as well. Arterial blood with fresh oxygen flows to the tissues and cells of body from the heart, and if there is a lack of oxygen in the blood, that means human's body tissues will not be oxygenated properly, and it can be dangerous to humans' health. That is why it is important to use pulse oximeter. Regarding to working principle of this device, pulse oximeter works on a simple principle. So basically, pulse oximeter shines a light through the human's finger, and by doing so, it can measure the amount of oxygen at blood. Light is emitted from the light source, which goes across the pulse oximeter probe and reaches the light detector. If a finger is placed between the light source and light detector, as shown second photo, the light should pass through the finger to reach the detector. So some part of the light will be absorbed by hemoglobin at blood, and unabsorbed part reaches the light detector. So there is a distinct difference between the wavelengths of light which goes through oxygenated and deoxygenated blood. By doing so, it can determine the level of oxygen at blood. In conclusion, fluid mechanics is a branch of mechanics that studies fluids and force on them. Fluids, and especially air and water, have a major role in our daily life, and almost 65% of our body is composed of water. Therefore, in future, it is anticipated to expand and improve the applications of fluid mechanics. That is the end of my presentation, and thanks for your attention.